Hello students, welcome back to Chemistry online classes. In the last class, we were learned the types of synthetic indicators and how they produce color in different acidic medium, basic medium, etc. so on. And today, I am going to familiarize you olfactory indicators. What are olfactory indicators? So you have learned that synthetic indicators like phenolphthalein, methyl orange and the natural indicators etc. in the last class. And olfactory indicators are the indicators which will give you smell in the acidic medium and basic medium. So the examples of olfactory indicators are clove, onion, vanilla essence, etc. It is universal indicator. Universal indicator is a mixture of more number of indicators giving different colors in different solutions. Okay, universal indicator is a mixture of number of indicators. So the pH paper and the pH solution can be called universal indicator. Now let's understand what is universal indicator.
The pH of a solution is defined as the negative logarithm of its hydrogen ion concentration in gram moles per liter. It helps to point out whether the given substance is acidic, alkaline or neutral. pH is measured on a scale of 0 to 14. The pH of a neutral solution is 7. Acidic solution is less than 7 and alkaline solution is greater than 7. The pH value of a solution can be determined using a pH paper or universal indicator solution that have a broad range of indicators exhibiting several smooth color changes over a very wide range of pH values. Our aim here is to find the pH of given samples using pH paper and universal indicator solution. Materials required: solution of sodium bicarbonate, 0.1 molar HCl, common salt solution, pH paper, universal indicator solution, tile and dropper. Procedure: Take a strip of pH paper and place it on the tile. Take a drop of common salt solution from the beaker using a dropper and pour it over the pH paper placed on the tile. Observe the color produced and compare it with the different color shades of the standard color pH chart and note down the pH value. Using a fresh dropper, take 1 drop of universal indicator solution and add it into the common salt solution taken in the beaker. Observe the color produced and compare it with different color shades of the indicators given on the universal indicator bottle and again find out the pH value of the solution. You can observe that in both the tests, the pH value of common salt is 7. Repeat the same step for finding the pH value of sodium bicarbonate solution and 0.1 molar HCl using fresh strips of pH paper, universal indicator and separate fine droppers for every sample. Through these methods, we can determine the pH value of 0.1 molar HCl and pH value of sodium bicarbonate. The pH value of 0.1 molar HCl is 1 and that of sodium bicarbonate is 9. Precautions. If you are using the same dropper for the test of all samples, ensure that it has been properly washed with water after every test. Make sure that the pH strips are kept away from chemical fumes.
Students, now let's discuss the first property of acid, reaction of acids with the metals. Okay, so what happens a dilute acid react with a metal? So generally you can write a metal reacts with acid to form the corresponding salt plus hydrogen gas. This you have to keep it in your mind. So this is the general equation. So what happens a dilute acid reacts with a metal? It will form the corresponding salt and hydrogen gas is produced. Okay, let's take an example. So take a metal above hydrogen which is there in the reactivity series. Which are all the metals coming above the hydrogen in the reactivity series? You can take any metals like magnesium, calcium, zinc, aluminium, any metals can be taken. Suppose if you take zinc metal and add any dilute acid, if I add dilute sulfuric acid, H2SO4. So that time you will get first the corresponding salt is produced. Zinc sulfate is produced. That is a salt. Zinc sulfate. Since the zinc is more reactive than this hydrogen is replaced as hydrogen gas. Hydrogen is replaced. Okay, is it balanced? It is balanced. So children, a metal plus a dilute acid will give you a salt plus hydrogen gas. Okay, this is the activity which is there in your textbook. Okay? And if you take another example, if you take another metal, if you take magnesium and add dilute hydrochloric acid. So what happens? First it will produce the corresponding metal salt. That is magnesium chloride. MgCl2. What is the valency of magnesium? It is 2. It has to be given to chlorine, magnesium chloride. And valency of chlorine is 1, which has to be given to magnesium. Plus, the hydrogen gas is common. Okay, the hydrogen gas is common. Is it balanced now? No. 2 chlorine, 2 hydrogen. So it is multiplied with the 2. Okay, this is another example of a reaction of a metal with a dilute acid. So this you have to by heart. A corresponding metal salt and a hydrogen gas is produced. Because one thing you have to note that the reacting metal should be more reactive than the hydrogen. the metal which is to be reacted should be highly reactive than this. Highly reactive than hydrogen. Okay, now let's discuss the second chemical property of acid. So what happens when an acid reacts with a base? So both the effects of acids and base gets neutralized. So children, remember this equation. When an acid reacts with a base, it will produce a neutral salt and water. Remember this general equation. This general equation, if you remember, you can write any example for neutralization reaction. Take any acid. If you take hydrochloric acid, reacts with a base. That sodium hydroxide is a base. So what happens? You will get a salt. A salt is the sodium chloride. NaCl salt, and a water is produced. That is H2O. Okay, this is the salt which is called sodium chloride. The salt does not have any properties of base and acid because the acidity is being neutralized by the base. Okay, this is a neutral salt. Or if you take any other example, or if you take sulfuric acid, dilute sulfuric acid, H2SO4, reacts with the sodium hydroxide base. So what happens? First, a water is produced, right? And which is the salt? The salt is sodium sulfate. So sodium sulfate chemical formula, sodium Na sulfate SO4. The sulfate valency is 2, which has to given to sodium. Okay, is it balanced? No, it is not balanced. You have to balance it by adding 2 here. Okay. Now it's balanced. So this is the sodium sulfate salt. Okay, these two are the examples. You can write any example. Any acid can combine with base to form the corresponding salt and water. Okay, this general equation you should by heart it. So after this you will study the applications of neutralization reaction in the coming module. Okay. Now the third property. So what happens when a dilute acid reacts with a metal carbonate and a metal bicarbonate? Or if you take any example of a metal carbonate, suppose here we can take a sodium carbonate. It is a metal carbonate salt. Sodium carbonate, Na2CO3. So reacts with any dilute acid. If I take hydrochloric acid, dilute hydrochloric acid, so what happens? You can see that a corresponding salt. So which salt is produced? Sodium and chlorine, that is sodium chloride. Along with you will get water and carbon dioxide. Water and carbon dioxide gas. Remember, if you take any metal carbonate, so reacts with any dilute acid, the corresponding metal salt and water and carbon dioxide is produced. So children, if you take sodium carbonate in a test tube and if you add dilute hydrochloric acid, you can see a brisk effervescence is formed. What is that brisk effervescence? The brisk effervescence is nothing but it is carbon dioxide gas is produced. A ladder is coming out of the test tube. That is called brisk effervescence. That is due to the formation of carbon dioxide gas. So any metal carbonate reacts with any dilute acid. So the salt is produced along with hydrogen, along with water and carbon dioxide gas is also formed. You can see the very next moment this gas is coming out. Okay, that is called brisk effervescence. Is it balanced? It is not balanced. Okay, now it's balanced. Okay, or what is metal bicarbonate? Metal bicarbonate means the corresponding bicarbonate, the corresponding metal bicarbonate. Bicarbonate is also known as hydrogen carbonate. So if you take sodium bicarbonate, so sodium bicarbonate is NaHCO3. This is sodium bicarbonate. Add hydrochloric acid, dilute hydrochloric acid, what happens? You will get the same product. So the sodium chloride is formed first, a salt. So along with you will get water and carbon dioxide gas. Carbon dioxide gas. Okay, I think if you add dilute acid to either metal carbonate or metal bicarbonate, the same product is formed, the same salt. This is the salt. Here the salt is same, and water and carbon dioxide gas is produced. Okay, now we are going to study the important test for carbon dioxide. So how will you test the gas which is formed is carbon dioxide? So test for carbon dioxide. So take the carbon dioxide gas which is formed after the reaction and pass it through lime water. What is lime water? Lime water is nothing but calcium hydroxide solution. The calcium hydroxide solution is called lime water. If you pass this carbon dioxide to this lime water, you can see the lime water turns milky, which means that lime water turns to milky calcium carbonate. Then you can confirm that the gas which is formed is carbon dioxide. Okay. So the presence of carbonate can be tested by using lime water. Lime water is nothing but calcium hydroxide solution. When you pass the carbon dioxide to this lime water, the lime water turns milky. Okay. And the last property, what happens? A metallic oxide reacts with a dilute acid. So what are metallic oxides? So the metallic oxides, you know that. So magnesium oxide is a metallic oxide. Any metal oxide, lead oxide is metal oxide. Zinc oxide is metal oxide. These oxides are formed by the reaction of the metals with oxygen, right? So if you take any metal oxides out of this and make them to react with any dilute acid, so you will get the same product, that is salt and water. So what is the nature of metallic oxide? Is it acidic or basic? The lower classes onwards you will learn that if you burn magnesium in the presence of oxygen, so you will get magnesium oxide ash. A white color magnesium oxide ash is produced. So is it acidic or basic? Take the magnesium oxide and add in water. So that time you will get magnesium hydroxide. So magnesium hydroxide is a base. So generally you can say that all metal oxides are basic in nature. All metal oxides are basic in nature. Okay, suppose if I take a metal oxide, that is copper oxide, make them to react with hydrochloric acid, dilute hydrochloric acid. So what is the product? You will get the corresponding salt, that is CuCl. Copper valency is 2, CuCl2 plus water is produced. Water is produced. Okay, so the metal oxides can combine with reacts with a dilute acid, can produce a salt and a water. This is the copper chloride, a copper chloride salt. If you take another metal oxide also, you will get another example of salts. So if you take zinc oxide, reacts with sulfuric acid, dilute sulfuric acid. What is the product? The salt is produced. Which salt is produced? That is zinc sulfate plus water is produced. A salt and water is produced. So if you take any metal oxides, the metal oxides are basic in nature, so that it will react with dilute acids. The product which is formed in the neutralization reaction, no, the same product is obtained here, the salt and the water. This is the zinc sulfate salt. Or if you take hydrochloric acid, you will get zinc chloride and water. Okay.